Every modern do-it-yourselfer or prototype maker like us, he's going to want to turn something around sooner or later, move something or bring something to life. To do this, he will have to use one of the available motors. If he wants to do it precisely, he has to do it either with a servo or a stepper motor, or a BLDC motor, DC motor, i.e. a gimbal like we have here, a gimbal without encoder or gimbal with encoder. What's the difference? Just now, I will describe both and show with an example. The first simple choice is the servo. The servo mechanism is cheap, but unfortunately not without its flaws. First, if we want to do something that has a microphone and we want to use a servo, you can hear it. It's a big noise that effectively interferes with any sound that falls into the microphone. If we have any solutions related to the microphone, for example, speech recognition, this solution is not very suitable. The second disadvantage is that we do not have a very precise determination of an angle. It may seem that this is quite accurate, but unfortunately it is not. We also have regulation here, but ideally to half a degree. It is really very hard to move such a servo. One more disadvantage, and perhaps the most important of servos, is this: that such a servo mechanism, even a metal one, breaks down very quickly. Really fast. In our project, which you can see here, where the camera moved very much up, down, left, right, and with everyday contact with such a camera, we see that motors fail very often. We had to replace them every now and then. That's why we used a different one, but maybe in a moment. Another motor that would seem ideal is a stepper motor. The stepper motor is, as you can see, large and has quite a lot of power, but as the name suggests, it is stepwise, i.e. it moves in steps. This causes the motor to shake the entire system during operation in which it is located. If you have a car, it's not a problem, but if we have some device that we want to be lightweight, it is pretty hard to put a motor in there. Another disadvantage is that this motor can miss steps, that is, it can lose its position. If it just has too much resistance, for example, if we want to move something which has a lot of mass, and will cause a lot of inertia at the beginning, it's going to be very hard for this motor to pinpoint the exact location it's in. Our next choice will be BLDC motors, i.e. gimbal motors. BLDC motors can be without an encoder or with an encoder, which I will talk about in a moment. BLDC motors without an encoder have a similar disadvantage to stepper motors, that they can lose a step. Admittedly, a step here is not some minimal movement, but depending on the number of magnets, it can be. For example, 1/11 or 1/7 of its position. Only this problem will be solved by the encoder, but more on that in a moment. Gimbal motors usually have such descriptions here. There is a number in the description. For example here, 3504. 3504 means winding size is 35 millimeters, its height is 4 millimeters. If we take a bigger motor like this one, the motor is marked 5208. Its winding size inside is 52 millimeters and a height of less than a centimeter of this winding. Gimbal motors also have the advantage that they often have a hole in the middle where we can run the wires, which is very convenient. Motor with encoder. You can buy an encoder or separately. We can connect it via I2C or PWM. 3 cables are enough to connect via PWM. Or as it is already connected here, we connect it together. If you do not want to buy such a set which is expensive, you have to admit that we can build it ourselves. We can print a handle for the motor. We add an encoder to this handle. And the encoder will be here. It is important that the encoder reads the magnet that is mounted here. There's no magnet here. There is a magnet here. This magnet, its position, is read by the encoder. We don't have that solution here. Now, let's try to assemble such a set on which we will show how to control gimbal motors. For this, we have our SaraKit board. On the board, we have connections to 2 BLDC motors, gimbal motors. And there are, of course, 2 drivers for them, but more on that in a moment. I'll connect the motor. I will connect one motor with encoder, the other motor without encoder. Okay. I connected 2 gimbals to SaraKit. The first gimbal is with an encoder, the encoder connected to port 1 and a motor connected to port 1 in SaraKit. And a second gimbal without an encoder connected to the second port. We do not have a power supply for this set. If we want to use this set in some mobile solution, for example in a car, it would be good, and there is a possibility to connect to a power bank. You need a power bank that has a USB-C output. The exact requirements of power banks is this one or even smaller, but with a USB-C output. The exact parameters are in the description. We connect it with an adapter USB-C 12 volt. There are some cables here though. We'll hide the one from the encoder. We have a ready set, although it will be easier for us to show everything if we connect blocks to the gimbal motors. Maybe we can connect a block like this. Such a part to connect the gimbal motor with the blocks. Of course, you can print it yourself or you can buy from us on the website. I'll speed it up a bit. I have the first program running. The first program is that. There are literally 2 lines as you can see here. We read the position of this motor from the encoder and transmit this position to the second motor. Let's see how it works. As you can see, the position is read perfectly. We can do it quickly or slowly. Now it's very fast. We can perfectly reproduce this movement and now I'm going to change one parameter. I'm going to change the speed of this motor so that it's not as fast as I'm moving here. There will be some delay. Look now. This motor is set up so it can't spin any faster than half a turn per second. See? You can freely adjust the speed at which it rotates. We can also freely adjust the power. I will change again now. Now I changed it to 0.2. See also that there is a rotation memory. Now let's change it differently. Now this is going to be the accelerator, and this is where we're going to move the motor. Depending on how far I stick the throttle, that's how fast the second motor will turn. Okay, let's see what happens now. We can move slowly or fast. Of course, the speed we can do, as it is on gimbal motors, is incredibly great. Now I have set another program. Here we have set 90 degrees on the motor with the encoder. Here we have 90 degrees on a motor without an encoder. Let's see what happens when I try to reverse and turn this motor over. Speed 1 is set, it just always returns to the given position. If only we could spin 3 turns, it will always bring us back to where it was. What happens when we want to force the motor to turn without an encoder? This motor has 11 zones. It will come back, but only to a very limited extent. If we turn it, it completely loses its position. It doesn't know we twisted it. That's why encoder motors are so cool, and there's so much more you can do with them. Let's see the same thing at speed 5. What other advantage do encoder motors have? The motor with the encoder works harder, the more we want to move away from the angle that is fixed. When the angle is as it should be, the motor consumes virtually no energy. If you want to twist it, the more you twist it, the stronger it reacts. If the motor is without an encoder and we want to keep its position, we need to give much more power, and we have to keep that power all the time. And that means the engine gets very hot, and this is one of its main disadvantages. There cannot be those elements that are the elements holding the blocks made of a material that will melt at a temperature. So that's a huge disadvantage. Finally, I would like to recommend to you such connectors. I will make a separate video about such connectors with blocks. Such a connector that costs about $1 or $2 depending on the material and print quality can help us to do it very easily with a nice connection with the blocks. Now we can build something that will drive. In a future video, I will show you a self-balancing vehicle which is really very easy to do with such a kit. But I leave that for the next episode.